to wait for BTEC and end to learn about the capacitance of three-phase asymmetrical transposed case. Asymmetrical transposed case. Okay. Here I am taking the conductors of three-phase. I am taking the conductors to take the transposition case. Okay. Now, am I arranging the conductors for asymmetrical? Yeah. I am taking the conductor positions. Conductor positions are 1, 2, 3. The position of the conductor is same. 1, 2, 3. Now, the distance from 1 to 2 and 2 to 3 and 3 to 1. 1 to 2, 3 to 3, 3 to 1. Center to center, those are the center to center distances. Okay. Yeah. It is, the distance is D12, D23, D31. Here it is also D12, D23, D31. Here also D12, D23, D31. Now, the position of conductors. I am taking conductor A, conductor B, conductor C for position 1, A at 1. And second interval, conductor A at position 2, B at 3, C at 1. Now A at 2. Now A at 3, B at 1, C at 2. This is third interval, the conductor A at 3. First, assume a point P is far away from the conductors. The distance from conductor A to P is, and conductor B to P and conductor C to B. This distances are D3P, this is D1P, this is D2P. Okay, first I am writing the potential difference from conductor A to P, A at position 1, due to all remaining conductors charges. It is 1 by 2 pi epsilon QA ln. First we have to write the distance from conductor 1 to P. The conductor 1 to P is D1P. Therefore, D1P by the self distance of conductor DA. The self distance of conductor DA. DAA is nothing but R. Therefore, it is R. From second conductor QB ln, the distance from conductor B to P. The conductor B to P is D2P. Therefore, it is D2P divided by the distance from conductor B to A. The conductor B to A distance is D12. Therefore, it is D12 plus QC ln the distance from conductor C to A. The conductor C to A is D3P. Therefore, D3P divided by the distance from conductor C to A. The distance from conductor C to A is D31. D, 3, 1. Okay, this is the way we will write the potential difference of conductor A to B, the A at position 1. Like that, we have to write the remaining conductor A at position 3, VAB2, conductor A. Here also 2 pi epsilon QA ln. The distance from conductor A to B now. The distance from conductor A to B now is, here also assume point P. Okay, it's far away from the conductors. A to B distance is now D to P, second position to P is D to P. Therefore, it is D to P divided by DAA. DAA is nothing but R. DAA is nothing but R. QB ln. The distance now from conductor B to P. What is the distance from conductor B to P? This is third position to P. The third position to P distance is D3P. Okay, therefore it is D3P divided by the distance from B to A. The distance from B to A is, the distance from B to A is D to 3. Therefore it is D to 3 plus QC ln the distance from C to B now. The distance from C to B is, its first position to B is, the distance from D1P is C to B. Therefore, it is D3P divided by the distance from conductor C to A. What is the distance from conductor C to A now? It is D12 for second position. Therefore, it is D12. Okay, now the conductor A at position 3, VAB at position 3 is, now I am taking this for the analysis. I am taking I will write this conductor A at position 3. Assume a point B is far away from the conductors. The A to P distance is D3P now. C to P distance is D2P. And B to P distance is now D1P. Now I am writing psi A D3. Sorry. It is V2. The potential difference A to B, A at position is 1 by 2 pi epsilon due to QA ln. The distance from 1 to P, the distance from 1 to P, A to P is now D3P. Therefore, D3P divided by A to A distance is R plus QB ln. The distance from B to P. The distance from B to B is D1B. Therefore, D1B divided by the distance from B to A now. B to A is D31. D31 plus QC ln the distance from C to B. The distance from C to B is D to B. Therefore, D to B divided by the distance from C to A. The distance from C to A is D to 3. D to 3. Okay, this is the third equation. Now, The average potential difference between A to P is VAP1 plus VAP2 plus VAP3 divided by 3. Okay, add this 3, you can get 1 by 3 into 1 by 2 by epsilon ln QA ln 1 by sorry, D1B D2B D3B divided by RQ plus QB ln D1B D2B D3B divided by D12 D23 D31 plus QC ln D1B D2B D3B divided by D12 D23 D31. Okay, now QB terms and QC terms both are same, therefore VAB equals to 1 by 3 into 1 by 2 by epsilon QA ln D1B D2B D3B divided by RQ plus QB plus QC into ln D1B D2B D3B divided by D12 D23 D31. Okay, we know that QA plus QB plus QC equals to 0. From this, QB plus QC equals to minus QA. Substitute here. What do you get? VAB you can write it as VA. Then write 1 by 3, 1 by 2 by epsilon QA ln D1B D2B D3B divided by RQ minus QA ln D1B D2B D3B divided by D12 D23 D31. Okay, now use the formula. The formula is ln of A minus ln of B. You can write it as 1 by 3 1 by 2 by epsilon QA ln D1B D2B D3B D2B D3B divided by R cube into D12 D23 D31 divided by D1B D2B D3 D3. Here D1B D2B D3B, here also same term get cancelled. Finally what you get? It is 1 by 3 into 1 by 2 by epsilon into QA ln D12 D23 D31 divided by R cube. Bring this 1 by 3 under ln, you can get 1 by 2 by epsilon QA ln third root of D12 D23 D31 divided by R. Now if you calculate the capacitance CA or C phase for unsymmetrical case, it is QA by VA. Substitute VA here, you can get 2 by epsilon divided by ln third root of D12 D23 D31 divided by R. Now substitute epsilon equal to 1 by 36 pi into 10 power minus 9. You can get 10 power minus 9 divided by 18 ln third root of D12 D23 D31 divided by R added per meter. C phase. Okay, this is the way we will calculate the capacitance of a three-phase unsymmetrical transposed case. From this formula also we can calculate for symmetrical spacing. Direct formula you get. In symmetrical, D12 equals to D23 equals to D31 equals to D. Substitute here what you get. See, for phase for symmetrical, it is 10 power minus 9 divided by 18 ln third root of d cube and this one get cancelled. Finally, what you get? 10 power minus 9 divided by 18 ln d by r and per meter. Okay, this is the way we will get for symmetrical and asymmetrical capacitance per phase. Now we will see one problem on unsymmetrical spacing transposed. Calculate capacitance. Calculate capacitance per phase of a three-phase unsymmetrical transposed. The conductors are placed at the corners of triangle, with sides of 1.5 meters, 2 meters and 2.5 meters, and diameter of each conductor. The diameter of each conductor is 1.2 centimeters. For this case, how we can calculate? Just now we derived the capacitance for phase formula for unsymmetrical transposed. It is 10 power minus 9 divided by 18 ln third root of d12, d23, d31 divided by r. What the given? d12 equals to 1.5 meters, d23 equals to 2 meters, d31 equals to 2.5 meters. And also the given diameter of each conductor is 1.2 centimeter or equal to 0.6 centimeters. You can get this 0.6 centimeters into meters, multiply with 10 power minus 2, you can get in meters. Substitute all the values here. This equation get C phase equals to 10 power minus 9 divided by 18 ln the root of 1.5 into 2 into 2.5 divided by 0.6 into 10 power minus 2. How much you get the capacitance? Capacitance equals to 9.6 nanofarad per kilometer. Okay, this is the way we will calculate the problems on capacitance for unsymmetrical transposed case. Thank you.